We are almost done talking about economics here. We are at the 3.3 study 4, the Green Revolution. As you learned earlier, a population of animals, rabbits for example, will eat and reproduce until they reach the carrying capacity of their habitat. Then a lot of the animals will starve to death. That sounds kind of grim. Eventually, the population will end up in a rough balance with the food supply. There are a lot of people in the world. Why has this not happened to people? British economist Thomas Robert Malthus asked this question in 1798 as England's population was growing during the early days of the Industrial Revolution. His answer was dismal. The only long-term limits on human population were war, disease, or eventually famine. He came to this gloomy conclusion because he noticed that the food production increases rhythmically as more people work and more land goes under cultivation. But, like rabbits, human population increase geometrically with each generation. So far, Malthus's predictions have not come true. Why not? The Green Revolution of the 20th century has led to geometric increase in food production. Page 2. Agricultural productivity. That's not food, that's what food eats, overheard at a salad bar. The food we eat comes from plants. This includes things like meat, cheese, and even processed foods that look nothing like found in nature. There's a limited amount of good land for plants to grow in. This is part of why Malthus's was so dismal. But what if it were possible to get more plants and thus more food from the same amount of land? The increase in food supplies in the 20th century is mostly because of rapid increase in agricultural productivity. That happened from 1940s through the 1960s. This period is often referred to as the Green Revolution. The world's population doubled between 1900 and 1960 and doubled again in the next 40 years. Because of the Green Revolution, farmers were able to make more and more efficient use of their resources. This resulted in a rising level of crop yield, the amount of output from a given area of planted land. This led to greater output of food even as inputs of land and seed went down. As the graph above shows, without the Green Revolution, there might not be enough food to go around for today's 6 billion people. You can see area harvested and seed planted remained virtually the same, but the yield and the production significantly grew. Page 3. Agricultural technology. How did the Green Revolution happen? The answer is a familiar one. Technology. Throughout the history of civilization, humans have been searching for better farming methods and more efficient tools and machines to increase productivity. There's been improvements in farming tools and methods throughout human history, but the 20th century saw important developments in technology that increased food production many times over. Terraced fields are a familiar feature of many agricultural landscapes, from the lemon groves of the Italian coast to the rice paddies of Southeast Asia. Terraces make efficient uses of hills and landscapes by converting steep rises into flat fields and increasing plantable surface area. They also provide a natural water flow that irrigates the lower fields with the runoff from the higher ones. The terraced fields make more efficient use of water supply, and they reduce erosion by conserving two of the most precious resources needed for farming: soil and water. And we'll go to, oops, that's the same one. Here's a seed one. Modern agriculture has focused on growing the most efficient crops, such as corn and soybeans. This practice, known as monoculture, involves growing a single crop over a wide area instead of planting different kinds of crops on nearby fields. Science has refined crops to allow farmers to use the best varieties in their fields. Farmers can then plant crops more closely, raising the yields. For centuries, farmers have been using animal manure to fertilize their fields, but in the 19th century, scientists learned the main soil nutrients that food crops use as they grow. In the 20th century, chemists created man-made fertilizers to meet these needs. Fertilizers allowed crops to thrive and avoid the problem of nutrient loss. Chemical pesticides, developed around the same time, helped reduce the damage done by plant-eating insects and other pests that can reduce yields and even destroy entire crops. Relying on nature to provide enough water for crops limits agricultural productivity. Farmers often need more controlled watering than nature provides to allow crops to survive. An early innovation used irrigation ditches to directly water where it needed. Later, people constructed dams to increase the available water supply. Some modern irrigation systems, such as the one shown here, use mobile irrigators or a pump-driven water supply. Often, water is pumped from deep underground where it is widely available. For centuries, farmers relied on strong animals to aid with difficult tasks such as plowing, harvesting, and milking. But even the strongest of these animals could only work so hard. With the invention of steam and then gasoline-powered machinery, farmers were able to move beyond animal-powered methods. Although modern farm machinery is very expensive, these machines can do far more work with animals can, and allowing farmers to plant and harvest more land with less time and effort. One of the earliest innovations in agriculture was crop rotation. Originally, farmers used a two-field system. They planted half the field and left the other half unused so that it wouldn't lose all of its nutrients. This preserved the land, but it also meant that there was less available land to produce crops. The three-field system introduced in Europe in the Middle Ages involved rotating two different crops through 3 fields. This allowed farmers to use more land, and by planting different types of crops, they were able to replenish the nutrients and avoid the buildup of pests. I think we got it all. Page 4. Increasing productivity, check here for your self-check. A major boost in output. Humans have been applying technology to agriculture and other areas of life throughout history, but the 20th century was a time of major technological innovation. The leap forward in farming methods and agricultural technologies resulted in a big jump in productivity in the middle of the century. The Green Revolution made it possible for farms to produce enough food to meet the needs of the rapidly growing population. Starvation and hunger have not ended, but they are now caused by food politics and distribution rather than worldwide lack of food. Take a minute to do a self-check here. And page 6, our summary. New problems. During the past 40 years, the combination of monoculture, planting, and the use of man-made fertilizers have produced a worldwide surplus of food, helping solve the problem of food shortages. Even if the world population reaches 10 billion people before leveling off, as it is expected to do so around the year 2050, the world should still be able to produce enough food for the people to survive. But if this revolution hasn't taken place without the introduction of some new problems, including the fact that monoculture has reduced the level of biodiversity in the world. The loss of biodiversity means that crops, and therefore humans, are more vulnerable. What happens when everyone grows the most efficient variety of a single crop and a disease develops that targets that variety? It could create disaster. Scientists are developing new and improved pesticides and antibiotics to prevent widespread destruction from plant and animal diseases. While humans have stayed ahead of nature so far, this could be a losing battle if biodiversity isn't increased in the future. There are other possible problems. The toxins in pesticides and the growth hormones used on animals could get into food sources and the world's soil and water supply. Advances in agricultural technology may be keeping the world from starving, but it is possible that we're hurting ourselves in other ways that might be harder to fix.